So folks, we're continuing our discussion of linear algebra, and the next object that we want to talk about is the determinant of a matrix. So we're going to continue to develop the idea of a determinant as we go along. For right now, we're going to focus ourselves on the computation. So for right now, all we need to know is that a determinant is a scalar value that we're going to associate with a square matrix through a particular computation. I do encourage you to read through this paragraph. It explains a little bit about what we're going to do. Eventually, once we get the language of linear transformations, I'm going to give you a better insight as to how we can interpret a determinant, what we can think of it as representing. But for right now, it's simply a scalar value, meaning, of course, a number that we associate with a square matrix. Okay, so let A be an n by n matrix. And we would denote the determinant of A one of two ways, either the determinant of A, and a little delay there, or as the determinant of A. So what we'll do is we'll go ahead and, so this is our notation for how we're going to write a determinant, one of these two ways. And then what we're going to do is we're going to learn how to do that specific calculation that I mentioned for a 2 by 2 matrix. We will discuss the idea of determinants for a 3 by 3 matrix, and then we'll give a general procedure for finding the determinants of n by n matrices. So here's the definition of a 2 by 2 determinant. And again, at this point, it's simply going to be a calculation. That's all we're doing. And later on, we'll assign some meaning to that. So the determinant of A is going to be the product of A times D minus the product of B times C. Okay. So what sometimes people like to do at this point is they like to give themselves a little diagram for a matrix here. We've got A, B, C, D, and they remember something along the lines of, making a little notation like that to help them remember the determinant calculation. So in our case, when we go to compute this determinant, we're going to take the product of along that first bar, I guess, that I drew of the x. So we've got A times D, and then we're going to subtract from that the product along the next, so B times C. All right, let's continue along. So real quick, folks, a little typo here. This should be a B, and this later on will be a C here. These should be the corresponding matrices. I'll get that fixed for your version of this. Okay. So let's say we were given B. It's a 2 by 2 matrix. Let's go ahead and compute the determinant of B. So the determinant of B, in this case, would be the product of along the first diagonal, 1 times 2. So 1 times 2 minus, and that minus sign comes from the formula, minus, and then the product along the other diagonal, 4 times negative 3. So just watch this, that there's a minus sign in our formula, and then you might have negative values in your entries for these matrices. So be careful with that. In this case, when we do that computation, the first product gives us 2, and then we'd have minus, and the second product gives us a minus 12, and so we get the determinant of this particular 2 by 2 matrix is 14. Okay. Let's try this once more, and let's see if we can make a little bit of an insight here. So here I'm asking you to compute, and I apologize for this, the determinant of C transpose. So we want to compute the determinant of C transpose. So to do that, we need to compute C transpose. So let's see here. How do we take the transpose of a matrix? Well, the transpose, when we do the transpose operation, remember, the row becomes the column. So my first column is going to be AB, and the second row, which was CD in matrix C, in C transpose, will be CD. Okay. Well, now if we go ahead and we compute this, just as we did before, following the formula for the determinant, notice that we're still going to have A times D minus B times C. Okay. So what have we just noticed? We've just shown that for a 2 by 2 matrix, that the determinant of a matrix A, let me make that a matrix A here. I don't know why I want to make that an A. It doesn't really matter what you call it. But the determinant of matrix A is equal to the determinant of matrix A transpose. And in fact, that's true for any n by n matrix, that the determinant of the matrix will be the same as its transpose. Okay, so we've looked at computing the determinant of a 2 by 2 matrix, and we will pick this up in the next video. Folks, today's video was underwritten by Microsoft Surface Pen. Microsoft makes really lousy Surface Pens that fail after just a couple of months. I've purchased 3 of them and had the same effect each time. Microsoft, if you'd like me to remove this ad, please pay me the sum of $300, which is equivalent to the amount of money that I've spent on your product, and I will happily remove this ad. Thank you very much, folks. Have a great day.